Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, The Future of Digital Engineering, Civil Engineering. My name is Amanda and I will be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Bentley Systems. Bentley Systems is the leading global provider of software solutions to engineers, architects, geospatial professionals, constructors and owner-operators for the design, construction and operations of infrastructure. Bentley's microstation-based engineering and BIM applications and its digital twin cloud services advance the project delivery project-wise and the asset performance asset-wise of transportation and other public works, utilities, industrial and resources plants, and commercial and institutional facilities. Today we will hear from two speakers, followed by a live audience Q&A session, and I encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our first speaker for today, Ross Harvey. As WSP's Director of Structures for the New South Wales region, Ross brings a practical approach to leading and inspiring teams for the delivery of holistic disciplines on complex building projects. Ross is a technically strong creative thinker who is advocating innovation through all aspects of the business, including in his role as WSP's digital lead for civil and structural engineering in Australia. Ross has developed engineering solutions for several complex buildings, and his work includes projects with major private and public sector clients, including ICD, Oxford University, Land Securities, Brookfield Multiplex and Lipton Rogers. Please welcome Ross Harvey.
Thank you very much for the introduction. My name is Ross Harvey and I am the New South Wales Director for WSP. And I'm going to have a talk through today through the different process of our design of a project lifetime. And I'm going to touch on some of the different stages of that design through concept through to construction and as-built. And then I'm going to talk about how each of those pieces can have a new digital tool chest and how those different processes might change in the future and some ideas on what we might be doing in the coming years. So here, as you can see in front of you, is a process for the project lifetime. You have the developer across the entire length of the project, as you would expect, and the consultants, which is the architects and the engineers, start from the when the developer gets on board through to the end. The contractor themselves gets involved at tender's time, unless there's an early contractual engagement, at around about the construction documentation. It's sometimes 30% or at the front, or 50% of construction documentation. Although that's in a traditional contract, of course, the construction documentation is produced and the contractor then comes on board to just build it out. And then you have subcontractor involvement, which might be a PT slab designer or maybe a steelwork connection designer through the project. So at these different stages, let's have a quick look at these. You've got the concept, you've got the schematic, you've got the design development, you've got the construction documentation, fabrication drawings, which is where the subcontractor produces them, and these are reinforcement detailing and also steelwork detailing, and maybe in this situation also post-tension design. Then you have the construction itself on site, and then there's aspects. And all of these stages have different arrangements that can be undertaken, different processes that we can use. More traditionally, for the concept and schematic stages, the engineer will take the outline of a design and sketch up how they might want to formulate the structure for the basement. So what we can see here is the basement scheme for 22 Bishopsgate in London, which I did. And we have 3 evolutions of design in front of us. In the end, there was like 8 or 9 different evolutions for the basement arrangement, depending on how the architect and developer wanted to use the space and in collaboration with them. Do we want more cars, more bicycles? Do we want more plant space? What's the different arrangement? This is better for constructability. This is better for usability, and how we might look at those. Now, during the concept and schematic stage, it's quite important to communicate the ideas that we have to the client in as many different ways as possible. Now, traditionally, these are done through sketches, and Bluebeam is more traditional now. Lots of people do that. I very much like to do the hand sketches to communicate those ideas, because I think a sketch speaks 1,000 words and everyone can really understand what's going on. So you see here some initial concept ideas of how we might demolish and build the tower for City Tattersalls through the middle of that building, which recently got DA approval. But throughout the whole of this process, there's the opportunity for parametrics to be used and for understanding of the building and giving new methods of design. So it's not just a case of sketching them, as important as that is. There needs to be a synergy between that older process and the new. So you see here Principal Tower in London, where we formulated different concepts for how do we build a 50-story tower over and around a train tunnel that is coming out of Liverpool Street Station. You can see the train tunnel there described as the 8-track coming through. It's 2 additional tracks on the 6-track live rail on the left-hand side. So it's a future track process. But you can see different formulations. Do we have a table form on the left? Do we have some sort of moment frame in the middle? Or do we go for inclined walking columns, which we ended up going for on the right-hand side? That was the final arrangement. And these were some of the models and conceptual ideas that we provided to the architect and developer and QS to be able to price and understand the methodology of how we wanted to design it. Now, throughout this whole arrangement, we can be looking at parametrics. Now, as you're all aware, parametrics is the ability to modify design parameters. This is done in many different softwares now. Probably the most well-known of it is in Rhino, with the use of Grasshopper as a bolt-on background. You set up your rule set, you change the parameters, and you adjust. What spacing should the frame be at? What density should the elements be? What curvature do you want? What is the depth of the truss? How do you want it to form? What you see here is a gallery for Louise Bourgeois in Paris, actually in Provence. The shape of the superstructure curve was provided to us by Jean Nouvel's architect, and we had to formulate how we wanted the trussing arrangement underneath that. And we took this truss arrangement, or the parametrics of it, to the architect, and they were able to slide and adjust it so that it fitted with what their concept, their aspirations for the structure was. They had a number of different light wells that needed to come through, and they wanted to fit the trusses around those light wells while still supporting the structure and getting a minimum amount of tonnage within the actual building. So that the parametrics of this particular structure was extremely key. But there's other things that we can do at this stage. Sort of, if it's a tower formulation, we can create an automatic load takedown arrangement, taking off of the floor areas rather than measuring off of a Bluebeam sketch and then summing it up in Excel and creating. You can get automated software or online tools that we're developing so that the conceptual outlines are automatically creating the tributary areas so that we have a fast arrangement for what is the load coming down a particular column. This allows us to scheme the size of that column and the trusses that it might be supported off the transfer arrangement to allow us to generate great schemes and opportunities to communicate different ideas to the architect and the client. And that's what it's very important to me, is to be able to provide options to the client. It's not about here is the final solution that I've decided the answer is, but rather to say here is a range of different options. So it's better for the project rather than better than for just the structure. So for this project here, we were talking with our architect. This is Admiralty Arch in London. It's been converted into a six-star hotel across the Mall, which goes up to Buckingham Palace. And we put in a 3-story basement in the forecourt here underneath the road. During the design development phase, you start to get involved in the Revit modeling and the cloud scanning. So the spatial arrangement of taking a scan of the heritage building to find out exactly where it is and how does that inform the design. Now, you can take that in the schematic stage, but it's unlikely due to the commercial route of a project. So it's more likely that this actual project, you get the scan in the early of design development, and that's where you start to do the investigation, where you have to do investigative works to find out actually what is the structure if the record set is not good enough. Doesn't give you the right amount of information. So can I find out, is this a steel, what size is this steel frame in this location? What size is this concrete column? What is the grade of this concrete? So that you can really back analyze and back calculate what you need to do. And then you can position your structure exactly where it needs to be so that you can weave your framework within the proposed area to the new connections. Now, design development, there are a number of different things that we do that is changing the paradigm for how we communicate design. Something that happens regularly now that wasn't when I started as an engineer is to produce a three-dimensional model of the structure. You can see here a basement for 22 Bishopsgate in London. The red area is the parts that we were cutting out to enable us to put a new 62-floor office tower through the middle of this building that was already constructed for the basement. So the grey is structure that is remaining. And this was extremely complicated and extremely challenging for architects, for the engineer, for us, and for the contractor when they were tendering to understand exactly what they were intended to do. We had a full set of drawings. We had a Revit model. But that communication piece is still needed. There's nothing better than the tactile nature of looking at a three-dimensional model and really understanding, right, I'm going to have to be cutting this area out and tying in new slabs here and new core walls in this location. I understand how this transfer arrangement is going to work because I can actually see it, even I bet in miniature. But during this process, as well as these things, as this communication process is going on, we will be undertaking load takedown and column designs, and there is an automatic or automation process that is being developed. No one is yet there with a fully automated systems, but everyone is driving towards it. The automated design of columns is once the load paths down the building are defined. The automated wall design, the automation of slab design. When you use the ubiquitous PT slab designer of RAM Concept, you still have to set the sides. You still have to locate the tendons and the drape of the tendons, the amount of reinforcement in there. Some parts of this are automated, but going forward in the future, these things will become increasingly automated. So it almost becomes the dangerous word of a black box. It will become more computerized. So the engineer will formulate the geometry of what's needed, and the computer will say, here I've looked at many different options, and this one is the lowest tonnage, the lowest carbon, the lowest amount of reinforcement, with acceptable limits on deflection, the acceptable limits on vibration, which are the sort of things that engineers are obviously always looking at and testing. So staying with the RAM, with 22 Bishopsgate basement, you can see the building on the left and what it is, a few months ago. It's clearly topped out now. And the cut and carve basement and raft arrangement on the right-hand side, and how this was transferred into RAM concept using in-house scripting that we had to convert from the Revit model that we had generated and accumulated, the thing that we used to 3D print. Interestingly, that 3D printing model, when we changed the design somewhat, we marked up the three-dimensional model with a pencil and a red felt tip to identify actually this area would be a lot better if we cut it out. And then that fed back into the Revit model to generate what the intent drawings, which were then also exported into RAM concept, so that you can see here the model that we use to design the reinforced concrete of that raft and the springs associated that we got out of our Plaxis model was all designed and interchanged. One of the things that is not used a lot, but is used a little bit at the moment, and that will become more, in my opinion, over the next few years, is VR clash detection. We, of course, do Navisworks clash detection and other softwares to understand how our structure interfaces with the architectural model and how that interfaces with the MEP pipelines and the fitting and finishings. But we, as yet, don't often look in VR. And that, to me, seems like it's a really good method for us to actually get a grasp of how a federated model is put together. You know, how I could see that we would all get together electronically, maybe nowadays, VR across a number of different offices remotely, and be able to have an in-model workshop where, rather than one person is flying around, we'll have a group of us floating around that actual model with actually be able to see where somebody is pointing and looking at it and seeing, actually, it makes sense why I have to make this beam slightly shallower to allow this MEP duct to run through, or why the duct needs to move to the right, or why this column can't come through this particular bedroom zone. You know, these sort of communications are very easily done face to face when pointing at a model and drawings, but in our 50% at home, 50% at work, you know, this new paradigm that we're all working towards, where everyone's working remotely for some, if not all the time now, we're going to have to start working new ways to coordinate efficiently. And that's a lesson. And I think a VR clash workshops is something that is going to become more common. So, you know, we move into the next stage of our process, which is construction documentation. Now, engineers take a great amount of time analyzing the structure. Is the sway right? Is the drift right? Is the wind vibration response correct? Is the deflection of the slabs correct? You know, and we're talking about automation of wall design and automation of column design. But the knotty detail of that is there are always elements that are outside of the common arrangement. They're outside of the traditional wall. They're outside of the traditional rectangular, square, circular columns. And these, you know, can be, for example, here on Principal Tower again, to be able to not bring a column down through the future 8-track, through that future railway corridor, we had to walk it back out the way, and we had to walk it back about 4 meters from the facade edge where it supported the tower above through to the mega piles that were adjacent to the rail corridor. And so to do that, there's a level of interface at the top and bottom, and it's always slightly interfaced by the architect about this is a residential building, so where does the bedroom want to sit? Can we move this wall a bit to the left without adjusting the column above? So there's a slight challenge, and so you'll see on the column in the middle and bottom there's a slight L-shaped shape that gave the support that was required to limit the deflection of the superstructure, but that then connected into the wall to walk it back away from the corridor. And then at that nodal point at the top and nodal point at the bottom, you get the stress flows of stress and strain through the concrete that you can see on the bottom right-hand side. Now, we needed to look very, very carefully at this. It was a highly stressed nodal junction, and so we had to do some complex analysis on it, which is, you can see components of it here. And those sort of things are very far away of being automated. That's going to take the skills and input of experienced engineers for many years to come. And that's what's good about the automation. We will be able to reduce the amount of design required in the more elemental bases, like a standard rectangular column that's just coming down the building. If we automate that, we allow ourselves more time to work on the complex problems here, which means that we are able to, rather than just saying it is a meter thick wall, we're about to optimize it. It's a 500 thick wall, it's a 600, it's a 350, whatever that wall size becomes, because we have the time to optimize it, to work at it in greater detail. Because we've taken the monkey out of the design room, we no longer need to crank the handle of doing repetitive design pieces. We can actually spend the time where we can really influence the design and give greater value to the design process. Now, as part of that thing of trying to automate, simplify processes, one of the things is multiple handling of information. We produce RAM concept models to design the floor slabs. And here you can see a floor slab out of Queen's Wharf, done in Australia. The design was done as a PT floor slab, which was then the analysis information was extracted and then put into the Revit model. And the PT tendons and the reinforcement required was put onto the construction drawings. You know, that tool chest has that tool chain has been created and done, and so it stopped the double handling or triple handle information. You create a Revit model. You separately had to create a RAM model. Once you created that information, you had to take it and you had to give it and hand mark it up onto a drawing to be redrawn in Revit so that it could be printed and handed to a contractor to build. That's triple handled information. Is slow, it's expensive, it generates errors, and all of these things. By doing an automated process from the very first to the last, you are both speeding it up, but also improving the quality of that product, which is perfect for everybody. But still, we're producing two-dimensional drawings. We're producing two-dimensional drawings from a three-dimensional object. And that's, to me, that's a really interesting situation. It's contrary to where we want to be, but it is absolutely what we are contractually obliged to offer at the day. The market is asking for us to provide two-dimensional drawings because the contractor wants two-dimensional drawings because everybody knows how to price and build from that. But we can produce more than that. We can produce a higher level of information. We traditionally provide design intent for our reinforcement. You know, we traditionally provide geometry for our concrete that is set out by the architect. You know, this can be auto set out. This can be, we can provide detailing for the contractor to build it on site. And if every element, every piece of reinforcement is pre-detailed, ready to go, you can get prefabrication of information. You can get that reinforcement cage created in the factory where it has already been pre-checked and every bar is known to be there. So it's a very simple check process. You no longer have bending or cutting of bars on site. You no longer have the risk to the contractor's program. You can get so much faster construction with less uncertainty in that construction if all of the reinforcement is provided to site in a prefabricated cages that have been pre-checked because that reinforcement that's been provided has been detailed by the engineer. Or you could take it a step further. You could have three-dimensional detailings so that you could go from the engineer's three-dimensional model straight into a robotic prefabrication reinforcement system. So it just comes out. It's a through point. There's no, again, somebody interpreting the drawing, somebody putting the wrong bar in because they didn't quite fit it in. The whole thing could be manufactured and ready to go. There are contractors out there that take an engineer's intensity map for their moment plots, the requirement for the reinforcement, the area of steel that comes out of our analysis, goes into their production line and creates floor mats that just roll out. So they take from the drawing, it goes through their system, giant rolls appear on site and get rolled out in site, already ready to go. The amount of time on site is reduced. The amount of errors on site is reduced. The amount of on-site uncertainty is reduced. The amount of people on site is reduced. And if you're doing that, you are also reducing the amount of potential risks. So health and safety is improved by a reduction of time, man hours on site. All of these things are possible if we make the leap from three-dimensional building models through to 2D drawings to 3D in construction reality. And there's a disconnect here that we will be changing over the number of years, but it will take contractual changes, and output from engineers' scope needs to be considered with the developer, the client, and the contractor. One part of the construction that we can also need to look at and can look at once these sort of things start coming to play is AR construction. If you have detailing to say where every reinforcement bar is, you could use HoloLens to identify where these bars are, and you can actually help people position things on site. You could wear them and it says the bar needs to go here, the bar needs to go there. You can then check that on site. So the quality of what is being produced increases again. You can also do drone inspections because those drones can identify what's on site and what's on the drawings, and you can match the two. The disconnect between the construction information we provide and what's on site is so far at the moment that we can't do those sorts of inspections because it's all intent, it's all matte. If it was identifying exactly what was going in, you can actually do that sort of higher future inspection arrangement. So that takes you to the as-built. That sort of information, that sort of review piece that you can do, can be used to create digital twins. We at the moment we produce as-builts. As-builts come from the contractor will mark up what the engineer's drawings to say exactly how close to the engineer's buildings within allowable tolerances, but how close they came and any variations that go. Then the engineer will then redraft those drawings to create an as-built drawing set. But digital twins are real live digital representations of the deliverable that the client keeps, and it enables an understanding of what the construction has been, what the construction is. It allows future forethought onto redevelopment, future forethought on maintenance. It's a fantastic future provision that will very much be coming to the forefront. People are talking about them a lot now, but they are not fully used on a lot of projects, but they are going to be becoming a lot more prevalent as we go forward, and I look forward to being involved in these going forwards. So I suppose the question is, what's next? There's some really exciting ideas here that we're right on the cusp of, and there's some very great things that would be able to be brought into our industry and be used by industry if we all consider to take just that little bit more step, push it just a little bit more. And it will take investment from a number of people, but the return on that investment for all parties is going to be manifold, and it will be the future's very exciting. The future's very exciting. Thank you very much.
Thank you, Ross, for your insights. I'd now like to welcome our second and final speaker, Dave Boddy. Dave is a Senior Industry Strategy Manager, Design Engineering with Bentley Systems, and has been in this role since the beginning of 2018. The role is focused within the ANZ region with a particular focus on road and rail opportunities, and entails a wide range of tasks including business development responsibilities through to constructioneering-related responsibilities. From 2012 to 2018, Dave served as a solutions executive for the road and bridges sector and within the mining sector. From 2009 to 2012, Dave served as a solutions engineer architect with the Bentley software within the road, rail and mining sectors. Dave joined Bentley in October 2001 when Bentley Systems acquired Geopack Corporation, where he served in numerous roles, including application engineer and business development manager. Dave holds a diploma in engineering surveying and a certificate in civil engineering. Please join me in welcoming Dave Boddy.
Thank you for that introduction and welcome everyone. And thank you for taking the time out to participate in this webinar, especially on a late Thursday afternoon. As noted within the heading of this presentation, I'll speak about our industry's move to this digital engineering approach and what this really means for the civil drafting team. But first up, let me provide some background around digital engineering into the what, who, and why. So let's start with the what. And I often get asked, what is digital engineering? Now, if you were to Google it, you would end up with 726 million definitions of what digital engineering is all about. Obviously, I haven't trolled through all of these. However, I have highlighted one, and this one's actually from Oricon, which I believe encapsulates the essence of what digital engineering represents. And it's important to note that digital data is only useful if it can be created. It's only useful if it can be discovered, and it's only useful if it can be accessible. And most importantly, and this is sometimes forgotten or overlooked by our industry, it must add value. It must add value to the asset, and it must add value to the life cycle of that asset. And it's funny, when people think of digital engineering, many automatically think of the 3D model or the BIM model. But in reality, and as noted within Oricon's description, the most comprehensible form of digital engineering is actually the digital data behind the model. And this opens up a window to a vast range of possibilities and opportunities. So therefore, what does the term digital engineering really mean for our industry? And this can be summed up in the fact that it means data, data, and more data, and all of this in a digital form. And a method accepted by industry as a vehicle for this data is probably another term you have probably heard of, the digital twin. The digital twin acts as a virtual representation of the physical asset or process, providing access and discoverability to the digital data captured over the life of the asset. And who is driving the digital engineering push? Well, it's a bit like our vaccination rollout. It started off slowly, but is now in full swing with many government agencies, many government transportation agencies, pushing this hard throughout Australia. And just like the vaccine rollout, some states are leading the push, with many transport authorities now mandating the creation, capture, and delivery of digital data throughout the life cycle of the asset. And the next question is why? Why, as an industry, are we doing this? So even though this graph is a few years old, it does highlight the lack of productivity within our industry over a 10-year period. In fact, in this 10-year period, we actually regressed. And when we look at other similar industries and their digitization index, we can see their productivity improvements are relative to their level of digitization uptake. So that's the what, who, and why with regards to digital engineering. So let's begin to ask some other questions about the industry's current state of play and how the shift toward a digital engineering approach affects those traditional deliverables. So the first question is, are 2D deliverables still required, and are they still important? And the short answer to this is yes, they're still required, and yes, they're still important. And the reasons for this are many and varied, and they range from just the long legacy of 2D drawings, which literally have been around for centuries. And we can include the entrenched CAD workflows and standards that have been in place for the last 30 years or so now. So this actually leads to an industry-wide understanding with this type of deliverable, whether that be the understanding from technical managers, technical reviewers, construction personnel, or the end client. As an industry, we understand plan sets, we understand cross-section sheets, we understand long sections, we understand plans with tables, etc. Now, Joe Public, when he looks at a long section, he may not understand it, but as an industry and as technical people within our industry, we do understand these 2D deliverables and how we can gather the information from them. Now, there are other factors that need to be considered for the reason why 2D deliverables are still required. Yes, historical and or generational familiarity reasons are a major theme. However, other factors such as the size and complexity of a project is also a consideration. So when we have a look at the images on screen at the moment, the left-hand side one is a simple road widening project. And 2D deliverables may suffice for such a small project, whereas the more complex interchange project may require a lot more 3D modeling work, digital data delivery, etc. We also need to consider other stakeholder requirements, i.e. design reviewers. How do they want to perform their review? Or construction contractors, how do they want the data presented to perform tasks such as quantity takeoffs, work breakdown, structure creation, cost codes, etc. And probably most importantly, it is about the end client's current requirements and their regulatory and contractual framework associated with the deliverables requested. But probably a more important question is, will 2D deliverables be required into the future, and will they be important well into the future? Now, if I look into my crystal ball, I'm going to say this is a yes, they will be required, and yes, they will still be of importance. However, this will be dependent on a number of those items I previously highlighted, i.e. the type of work being designed, the scale of the proposed works, the number of disciplines involved, what the downstream stakeholders require, including what the regulatory framework is and the contractual requirements are around the process. Now, the inherent value of 2D drawings is the efficient manner in which the drawing itself conveys that specific information for the intended user of that information. Now, this may sometimes be difficult to convey within a 3D model. Therefore, and at the end of the day, it is really about the efficiency of communicating details of the design to particular stakeholders. Therefore, I foresee 2D drawings will still have a role to play into the future, albeit possibly at not the same level of influence they have today. If we are to assume that 2D drawings will be important and play a role into the future, it is also important to note that these 2D drawings will need to be derived from the 3D models or the BIM models to the fullest extent possible. So at Bentley Systems, we are complying with owners and clients' requirements and are striving to make this as automated and efficient as possible. So in the example shown, we use the cross sections to highlight this capability. And as the industry and software developers such as Bentley Systems advances, we will see more of traditional drafting requirements automated within the traditional design process, therefore blurring the demarcation line between the designer and the drafter. And in this example, we combine the plan view and profile view to create the combined plan profile 2D drawing sets. Specific ANZ-based CAD drafting standards are adopted to ensure compliance with these CAD requirements. Along with the overriding requirements, the 2D drawings need to be derived from the 3D models to the fullest extent possible. However, drafting solutions such as MicroStation can still be leveraged to provide support for the 2D drafting requirements, allowing the drafting team to fully embellish and complete 2D drawing requirements. Now, I'm going to take a slight detour here in an attempt to get people to think about the future direction industry is taking. And I'm going to use an example which will be, I think, both contentious and hopefully thought-provoking. So on the topic of cross-sections and long-section plan sheets, one has to ask, what value to the project will these have in the future? Now, I know this is sacrilege to ask such a question within a heavily focused civil drafting event. However, as an industry and as we progress towards the digital engineering approach, we really do need to consider such questions. I understand the production of these outputs take an inordinate amount of time to produce and reproduce at regular project milestones, and I understand they still have a role to play today. The question is, how much value and influence will they have in the future? And maybe because of the digital engineering transition or the paradigm shift that the industry is experiencing into the digital engineering approach, maybe it's time for industry to recalibrate. So let me try and explain. In the 2D drawings of cross sections, these were used extensively for construction purposes. Now, as a surveyor, and I'll admit this was a long time ago for me, I was always referencing the cross-section sheets as the project progressed. For example, I would use the elevation values associated with the back of the curb to define elevations on stakes used for construction grading purposes. However, with the advent of machine control and machine guidance capabilities, a more digital approach is performed where components of the 3D models are actually uploaded to the dozers or the graders, negating the need for a large number of construction stakes associated with the road project. And cross sections and long sections were also used for other construction purposes. In days gone by, construction personnel would use the cross sections to determine volumes required for pavement and other various base layers, your sub-base or your base. However, a more digital approach is available today, where the 3D models of the project are actually provided to expert solutions which calculate volumes from objects and then perform optimized material movement calculations across the entire project, incorporating aspects such as resource, equipment, and/or machinery requirements, and of course, scheduling to provide a 4D review of the project. And this is all contained within a true digital-driven process. And cross sections and long sections are also used for design review purposes. As a person undertaking the design review, critical aspects of the geometry are evident within the cross and long section sheets, and checks to standards are performed, with any non-compliance issues redlined with additional comments of the non-compliance documented. However, today a digital approach can be performed, where 3D models of the project are provided within a web-enabled environment, providing the option to view profiles and cross-sections, and also perform the same sorts of analysis with respect to critical geometric data associated within the roadway. Additionally, a digital issue resolution service is offered that allows a more efficient and auditable tracking of non-compliance issues, ensuring the entire process is digitally captured, providing opportunities for the data to be more easily created, managed, and discoverable. And how are cross-sections and long sections currently used within the owner's environment? Maybe they also perform an independent review of the project's profiles and cross-sections. However, I suspect these plan sets are actually filed, possibly never seeing the light of day again. Now, I may be a bit cynical in my last comments, as the geometric layout of the proposed roadway is vitally important to the owner. However, as mentioned earlier, owners are now requesting a lot more data be delivered, and all this data needs to be delivered in a digital form. And talking about owners' request for more digital data, if we were to review Transport for New South Wales' more recent version of their DE standards, or their digital engineering standards, we can see the amount of digital data or metadata they wish to associate with each design asset or object, whether this be the wearing course layer of the pavement, or its curb, drainage pits, light poles, guardrails, etc. As you can see on screen there, if you look at the right-hand side image capture, this is the metadata or the extended attributed data that needs to be attached to each and every object within a Transport for New South Wales project. So the scale of the data associated here is hard, if not impossible, to record within a 2D plan set environment. And obviously this would not provide the owner with an ability to easily find, access, and use this data for downstream purposes. Therefore, this data needs to be captured digitally and maintained within a digital environment. So at Bentley, we believe this will be in a digital twin, whereby addressing the very basis of the digital engineering definition previously identified, i.e. the computable data behind the model that opens the window to vast possibilities and opportunities. As mentioned, I still believe 2D plan sets will be required into the future. However, the question is, will reams of long and cross-section plan sets in their current form, their size and regularity in which they are produced, prevail into the future? Now, the writing may already be on the wall, and I expect these will not be required in their current form within the not too distant future. And to be honest, there are probably other examples we could identify where we look at the value of the data provided by 2D plan sets versus other mediums of information transfer, which align more closely with the digital data approach. I suspect over the next few years, as the need for digital data delivery increases, conversely, I think we will see a decrease in the value and need for a number of 2D plan sets. So let's jump to the next question. How is productivity affected in today's climate? Now, I like to say the industry is in the middle of the twilight zone, where we haven't quite fully embraced the new digital engineering paradigm, and we have not let go of those historical processes and deliverables. Therefore, and today, the expectation on projects, and in particular the expectation on engineering consultants on these projects, is to provide both sets of deliverables, i.e. the traditional 2D plan set deliverables and the newer digital deliverables. Now, when you couple this with the fact that the civil designers are now having to design a more detailed design model, so in other words, a more detailed and comprehensive BIM model consisting of real-world 3D objects representing those assets rather than just a group of strings and points and surfaces, the timeline needed to produce all these deliverables is quite demanding. So given the above increases in requirements throughout the course of a project, productivity is adversely affected. Now, as we know, over the last number of years, project timelines tend to shorten and not lengthen. So as an industry, we are finding we need to do more with less. So let's ask the next question. What could a new workflow look like, and how do Bentley solutions support this approach? So as shown within a civil design workflow within a dedicated civil design solution such as Bentley's Open Roads Designer, designers can relatively quickly produce those cross-section, profile, and plan profile type deliverables. The value of this approach is it addresses the core new requirement coming from those clients with respect to the fact that 2D drawings will need to be derived from 3D models to the fullest extent possible. Additionally, this workflow provides increased value and productivity improvements coupled with reduced risk due to the fact that drawings are now linked to the 3D design model, therefore allowing a fully automated or semi-automated update of the 2D plan sets when design changes occur within the design 3D model. Now, this is what industry describes as a model-centric approach to drafting. So software vendors such as Bentley Systems will continue to build out, automate, and streamline the 2D drawing requirements within the design application environment to ensure these can be produced quickly, accurately, and within compliance to current standards. Obviously, additional information may be required to these drawing sets, and additional drawing sets will also be required to fulfill the current and necessary 2D deliverable requirements. Therefore, today, I still see the drafting team remaining as an integral group within any civil project who are required to complete these 2D deliverables. Bentley Systems provides applications such as MicroStation or PowerDraft, which are used by the drafting team to embellish those initial plan sets produced from applications such as Open Roads Designer to ensure they are fit for purpose and in compliance with the local authorities' CAD standards and requirements. So with the possibility of the 2D drawing requirements diminishing over time, and given the expected influx of digital data deliverable requirements in the future, the question is this a role the drafting team could assist with? Just as the drafting team are responsible for the delivery of 2D drawing requirements to clients, could they also fulfill a role within the delivery of digital data to clients? Now, I understand this is the domain of the project's BIM coordinator and DE teams. However, and at the moment, most of the heavy lifting with respect to the creation of current requirements around digital data is undertaken by the design teams. I personally don't believe designers are the right personas within the workflow to be charged with creating this extended attribute or metadata that's needed by the clients. I'm sure over the next few years, there will be further digital data requirements coming from clients, which will need to be addressed. So as this is a thought leadership event, maybe these are some thoughts our industry needs to address. Personally, I believe the drafting team are perfectly positioned to take on a critical role within the digital data delivery workflow. Their current experience in providing required and in compliance 2D deliverables to clients is well documented, and therefore extending these capabilities into the new digital data delivery process, I believe should be considered. So therefore, and to summarize, we'll just step through these questions again. So are 2D deliverables still required today, and are they still important today? So in today's environment, this is a resounding yes and yes. Will 2D deliverables be required and important well into the future? So I believe in tomorrow's environment, this also will be a yes and yes. However, their importance may diminish over time. What are the likely challenges faced by industry tomorrow? So there's going to be a large expectation for our industry to be able to create, manage, and deliver digital data, and this will significantly increase, and the industry needs to be prepared for this next wave. And lastly, what will the role of the drafting team be, and what would it look like in the future? So this is really the $64 question. However, if as predicted, the 2D drawing requirements will diminish over time and digital data delivery requirements to clients increase, i.e. that metadata or extended attributed data, I would suggest there is an opportunity for drafting team members to easily migrate into a team which ensures the same level of expertise thoroughness, and accuracy applied to 2D deliverables be leveraged within a group charged with delivering digital data. So thank you for your time today, and I'll hand back to the host for the Q&A session. Thanks, everyone.
Thank you. Thank you to our speakers. And I think we'll both agree, just to quote Ross Harvey, that the future does look very exciting. It's now your turn to get involved. As always, Ross and Dave are here to take questions from you. The way to do that, if you could just put your question in the YouTube chat box, and if you'd like to put your name, but please tell us who the question is for. Big thank you to everyone who sent through questions on registration, and we might start with some of those. Dave, I might start with you. And we have a question that's come in from Devney, and Devney is in South Australia, so good afternoon, Devney, asking how can BIM and GIS data platforms be integrated into the design engineering to consider the built form requirements and the environmental constraints, such as water courses, sewerage lines, etc. Thank you, Devney.
Yeah, thanks, Amanda. So the term used there in the question was design engineering, and I'm not sure if the question should have been about digital engineering, but anyway, I'll try and answer both because they've got a slightly different connotation, especially from a software vendor perspective. So we see design engineering. They're actually the authoring applications, the software used to create the BIM models or the 3D models, whereas digital engineering is actually a process which could incorporate the 3D or BIM model into the process, but there is a raft of other digital data that's associated to a digital engineering process. And digital engineering really is about not only the creation of digital data, but also the capture and the management of that digital data, making sure that it's accessible and discoverable. So there's two different terms there, but seeing the question was around design engineering and how can BIM and GIS data platforms be integrated into that. I'll just talk from a Bentley perspective. So with our authoring applications, whether it be OpenRoads Designer or OpenRail Designer or MicroStation, we provide capabilities to integrate into a GIS platform. So whether that's the Esri platform or whether that's the MapInfo platform, so we can bring that into a design workflow and provide the designer with some context about the existing state of, whether it is a water course or whether it's, a sewer line, etc. So that capability is already embedded to the software that Bentley delivers, that capability of integration. With respect to BIM models, especially on large projects where you might have multidisciplinary approach, there's structures, there's bridge, there's, road, there's rail, etc. Now, even though Bentley Systems wishes they were always using a Bentley system-based authoring application, we know that's not going to be the case. However, what we can do is, as we just do with the GIS, where we can integrate with those other file formats from those, what we describe as third-party vendors. So that integration is also available within the Bentley stack. So BIM and GIS data platforms can be easily integrated into that workflow and provide that context for the designer as they work through their design engineering process, which is creation of their particular 3D models or BIM models. Now, interestingly, within our sector, within our industry, within the civil transportation industry, BIM models of existing infrastructure is really quite rare. I mean, when you think about our infrastructure within the civil world, you're talking about roads, rail and bridges. Some of these roads have been around, and bridges have definitely been around for 50 plus years, and there aren't any CAD-based BIM-derived models for those. But there is a way around that in which we introduce what we call a reality model. So at Bentley Systems, we can provide capabilities that take digital photogrammetry and create 3D models of the as-is state down to a resolution or to an accuracy of millimeters. So they serve as that existing state context within a design workflow. So you can bring that in and harness that power. So then when we talk about digital engineering, so in essence, digital engineering is, as I mentioned, is that process. A vehicle used to provide support for a digital engineering workflow is the digital twin. So a digital twin, simplest form of the digital twin that you can think of as it leaves design is a federated model. It's a federated BIM model. And likewise, within that digital engineering workflow, at Bentley, we've developed a open source, open access digital twin environment for infrastructure. And that also has the ability to provide that integration with those other BIM models from third parties, and integration with GIS platforms, whether it be WMS or WTMS formats, etc. So there are available today. So there is integration opportunities at both what I call the design engineering level and at the digital engineering level.
Thanks, Dave. And we've had a great question that's come in from David in South Australia. Good afternoon to you. And as you know, we normally get a lot of technical questions. So this is nice because it's talking about the people side. And this is directed to you, Ross, David's asking, how will digital engineering impact the recruitment profile and industry partnering needs for engineering firms? Thanks, Ross.
Oh, thank you, Amanda. That's a very interesting question. I think it is definitely going to impact the recruitment. You can already see that in a number of different adverts for engineering roles at the moment. There is an increased drive for people with parametric capabilities and the ability to offer those three-dimensional modeling that sits within the engineering field. And then so that's really driving a skill, an upskilling of our industry base. Companies are seeing that their firms are missing a capability or are weaker in that capability, and they're really driving towards trying to get more people in their teams with those capabilities. So that's a direct impact of this sort of digital upskilling of the entire industry. And this is, architects have been there for many years, and engineers are slow to the table, but we are getting there, and we're getting there quickly to really help inform the design process. And that's very exciting to be involved in that, to make it more of a synergy, more of a collaborative form to test the options with architects. So that's a very good thing. So yes, absolutely, it is going to impact people. I recommend that people upskill in these areas as much as they can.
Thanks, Ross. Just staying with you, we've had a question from Dexter, and Dexter's currently in the Middle East. Good afternoon. Asking you, Ross, is this digitalisation in engineering more prevalent in construction as a sector rather than the traditional way?
Is it more prevalent? It's more prevalent today. I mean, certainly we're decades behind other sectors such as the aerospace. I mean, and the automobile car manufacturer. They've been doing it for years for both wind tunnel testing, for lowest material design for the elements, but they are componentized and product orientated design processes. So they can spend a month designing to the absolute nanometer on a lowest material value for a nodal junction in something in the engine or chassis of a car or airplane. Within our space, every product that we design, whilst it might use prefabricated components, generally is unique. We don't design a building that is used more than once. We don't copy and paste around, so we don't have that option to really dig into it. But I do think that we have more opportunity to analyze and to reduce some of these elements, especially if we automate some of, as I said, tongue in cheek, take the monkey out of the design room. If we can automate the simpler systems, we can really spend more time on the exciting and more challenging aspects of the design process.
Thanks, Ross. And over to you, Dave. We've had a question that's coming from Joel in Queensland asking, is there any development in linking scheduling software to BIM models? For example, interactive work scheduling. Thank you, Dave.
Yeah, so I know, well, actually, I probably showed there was probably one small video within the presentation that ran through that process. So that is an area that I know Bentley, we're spending a lot of time looking at that functionality and capability in that 4D area and linking it to the infrastructure model or the federated model. And then linking it obviously to the schedule, whether that's P6 or Microsoft Project or whatever the case may be. So highlighting the interaction between the schedule and the model over a timeline. So I know from our Synchro Construction group, that's a major focus. That's a level of effort that's been undertaken over the last few years. That's starting to bear fruit actually at the moment. So but that will only develop further. We'll do a lot more integration within that space. We'll get to introduce aspects such as 5D, 6D, integrating that within the schedule and timeline as well. So short answer there is yep. There's a lot of work that's been undertaken in that specific area.
Thanks, Dave. And in Dave's presentation, we talked a lot about that 2D would still be required, or that it may decrease. So it'd be interesting, Ross, to get your view. We've had a question coming from Lina in New South Wales who's asking, it seems that project controllers are trying to rely totally on 3D models and handheld devices to manage their projects. They seem to have an idea that 3D is better than 2D and not just complementary to each other. Your view, Ross?
That's an interesting one. I do think that people are driving towards three-dimensional information as a future deliverable set, but I do believe at the moment that they are absolutely complementary. Certainly, it is an unusual project where the three-dimensional data is the design deliverable. It is still normally contractual that the two-dimensional drawings are what we are contracted to produce, and there's certainly a conversation to be had for the entire design stakeholders about that. I feel that three-dimensional deliverables are the best. As I said in my presentation, I think that they will be where we get to. They will be what we end up building. It seems odd to me that we design in 3 dimensions, we model it in 3 dimensions, we analyze in 3 dimensions, then we produce a 2-dimensional drawing to then build a 3-dimensional model. But that is, traditionally humans have used 2-dimensional forms to communicate for eons, so I can see why we do that. It's kind of hard for people to visualize sometimes how they're going to build it and how they're going to set it out. But we really need to upskill and learn how to do that. I think it will happen. I think if somebody came to me tomorrow and just said, your next building is going to be 100% three-dimensional and no drawings, I think I would raise an alarm bell to say that I don't think that the supply chain, nor that the incumbents, both ourselves and others, are yet ready to be able to do that. So I think for the short term, at least, that the two-dimensionals and three-dimensional deliverables are absolutely complementary. And we should use three-dimensional models to raise questions about how the two-dimensional might be produced and what it might be lacking in, and vice versa. So I do think that there's a long way to go yet, but it's a good path to be on.
Thanks, Ross.
Yeah, if I can jump in there, Amanda. Sorry, Amanda.
Yeah, sure.
I totally agree. Totally agree with Ross. I think we're in this transition period, and I think what it boils down to, it's the value of the 2D drawings. If there's value of 2D drawings for specific stakeholders, then they will remain. If a digital or a 3D, using the 3D model and using a digital workflow can provide that same level of value or enhance that value, then I think you'll see that the 2D drawings may, the requirement for those 2D drawings may diminish somewhat. I know on some projects, again, just within the civil space, I know some projects in the US, for instance, some of the Department of Transportations have gone with just a full digital 3D data. That's all that needs to be delivered type project as pilots. And they're learning that you still need that 2D context there in certain circumstances. So I think there will be that mix for a while yet, until we find our feet.
Thanks, Dave. And I was going to say that it has been a conversation about the pace of change around Engineers Australia and its events and its community for a very long time. And you were talking about the transition in, which is why there's a great question coming from Dimitrich in WA asking you, Dave, how do we currently quantify the rate of change in our sector towards digital engineering?
So again, I'll talk from a civil transportation perspective, and I think I touched on it in the presentation. We've been, to be honest, as an industry within ANZ, we've been slow out of the blocks. I mean, there have been other regions throughout the globe that have been a bit quicker out of the blocks. Thinking the UK here, some of the Nordic regions, some of the European regions, who have embraced this a bit quicker than we have. For us, with the civil infrastructure or the civil transportation infrastructure, and when I'm talking transportation infrastructure, I'm sort of talking more at the higher level, not down at the local authority level at this point in time. There's probably still a long way off before embracing the whole digital engineering paradigm. But when we talk about the state level, it really needs to be driven by government for our industry. I mean, we're the ultimate owners. The taxpayers are the ultimate owners of all the public infrastructure, but it's the state governments that manage all that public infrastructure, the roads, the bridges, the rail. So it really is incumbent on them to put forward these guidelines and specifications and standards all around digital engineering before the rest of the market embraces it and takes it on board. Now, within ANZ here, the government, the state, and I'm just talking the state road authority, rail authorities. I won't say have been slow to embrace it. There's been a lot of work that's done in the background that hasn't filtered through to the industry just yet. Well, that's probably not quite so. It's starting to filter through to the industry now. So we're seeing the results of a lot of work that's been done over the last 4 or 5 years by state road and rail authorities that are starting to filter through in terms of requirements and standards and guidelines that industry now, who are charged with developing these projects, need to adhere to. So even though we've been slow out of the blocks, the rate of change now within the sector is really starting to gain momentum. Now, across ANZ, it will be spotty, depends on what state and what project you're working on within a particular state within Australia, because some state road authorities are more advanced than others when it comes to digital engineering. But rest assured, we're heading down this path, and we're not going to do a U-turn. So I think the momentum's there now, and the rate of change is definitely noticeable increase in that.
Thanks, Dave. Over to you, Ross. We've had a question coming from Brent asking, will automation of part of the structural design give us more time, or will it just result in reduced fees and less time? Ross.
Oh, that's a challenging question, because a lot of people see that automation is a time saver, therefore the fee can be reduced, and therefore they can bid at a lower rate because people are spending less time on a project. Whilst to some level that is true, I feel that actually the value that engineers bring to the conversation of buildings and the design of the buildings is extremely important. So the level of automation should be used to remove the repetitive items out of the design process, and we should spend that time looking at the more complex arrangements. The digital tools that we're using today and the involvement in heritage projects and reuse of existing building structures, that is going to be an increasing feature of our future as we drive towards net zero, is going to mean that we're going to need to spend more time investigating existing structures, thinking about how they work, how do we interface them, how do they move, how do we design these tricky items. And we need to spend more time on that. So the use of automation to design more regular common elements will enable us to do that, and to provide a better service to our clients, and developers and architects. An engineer's value to the project is huge, and if they are given the financial if the financial leverage to be able to bring good thought and time to a project, the value to the end client is a multiple times the amount of the actual consultant cost. The consultant costs are minuscule in relation to the overall construction value of projects, and I don't think that smaller fees and a commoditization of the products that we produce is the right route for good design, for quality design, for safe design. We need to be doing considered good thoughts on all of our designs, and to do that you need time. So I do not think that automation is going to be a drive to reduced fees. So no.
Thanks, Ross. A question coming from Alex. Good afternoon, Alex. To you, Dave, asking, hi Dave, do you foresee a more user-friendly workflow for the civil design engineer in the industrial and commercial development space in the future? Currently, it's not user-friendly. Dave?
So I do see it becoming more user-friendlier. into the future. Now, is the future 1 year, 2 years, or is it 5 years? I know within that space, I know we're doing a bit of work. We've actually acquired a company recently, looking at doing more about optimization within that space. So within a civil context, generally within those, I won't say smaller projects. They're probably mid-sized projects. Money is generally tighter within those. The budgets are generally tighter. So I know within Bentley Systems, we're doing a lot of work with trying to optimize earthwork movements, retaining wall structures, looking at alternatives within those particular fixed industrial or commercial sites to ascertain what could be optimized from a cost point of view. So running and using the cloud to go through and do that optimization process. And that's from a sort of a bulk earthworks point of view, but also from a drainage point of view. So there's a number of things that we're starting to look at as a company that's specific to that particular industry. And we've got some tools and capabilities that are available today that'll allow someone to do the conceptualization pretty quickly using that optimization type routines. But obviously the next step is taking that through from conceptual through to preliminary right through to the detailed design. So it's coming. Alex, it's probably not coming quick enough for you, but I know from a vendor perspective, we're applying a fair bit of effort within that area.
Thanks, Dave. I had a great question come in for you, Ross, from Ransley in WA, asking Ross, how do you see progress towards LOI as described in BS EN 17412 across the breadth of information and actors' use cases? So they see a place for standardised workflows to achieve design commission, beneficial use, and handover milestones, which can then be customised on a case-by-case basis. Thanks, Ross.
Yes, there is definitely a place for standardization of that deliverable with milestones. There's a recent standard that might be worth looking at, which is BSEN 17412, Building Information Modeling and Level of Information Needed. And that basically introduces methods for describing information to be exchanged and new areas for consideration. With object details, dimensions, location, that sort of thing. I do think everything still needs to be formulated within a BIM execution plan, and clearly the level of information it has to be defined by somebody who knows what they're talking about. When you have an expert client, they will already have these predefined. But a number of times you will pick up a client or developer that doesn't actually know, and you as the specialist needs to guide them through the sort of level of information that they should expect and want as a trusted advisor to that party.
Thanks, Ross. And we've had a great question, and we've got quite a lot of questions. We talked about the transition, and I think some of the questions coming through, there's a combination of frustration maybe with the speed of transition. And Taylor in South Australia is asking you, Dave, many organisations specify the delivery of a digital model for any given project and then summarily fail to make use of it. How is the project lifecycle loop to be closed to drive fully integrated digital engineering and asset management? Thanks, Dave.
Yeah, that's a great question. It's probably a question you need to ask your road authorities. They're the ones who are mandating the delivery of digital models and digital data. And I use the two terms, digital model and digital data. Through the life cycle of an asset, from conception through to the detailed design to actually constructing it and then operating and maintaining that asset, there's a different focus depending on the persona. So through that project delivery, the creation of the BIM or the 3D model is pretty central to that project delivery, the design and construction phase. Yes, as a group, as designers and construction contractors, we add metadata to those particular objects. But it's really the 3D model is more or less the focal point through that project delivery phase. However, once it gets into the O&M phase, the actual geometric model isn't so important. It's for the owner operator, it's the metadata. The metadata is really what they're chasing. And we're seeing that with Transport for New South Wales, where their digital engineering standards, their version 4, onto every object that a designer now designs. Not only does he have to think about the geometric modeling of that particular asset within the model, there's a raft of metadata that needs to be associated to that particular object within the model. Transport for New South Wales is, currently there's 65 bits of extra information. It's Uniclass classification, it's asset management classification type data that needs to be associated with that. Now, as a designer, it's, I won't say it's a hindrance, but it's something, as a designer, I'm really focused on the geometric layout. However, that information that's been associated at that point in time is important. Mightn't be important to me, but it's important to someone else down that life cycle, i.e. the owner. So the owner is now, even though they're maybe asking for the design model, what they really after is the data that's associated to that design model. That's the data that they want to try and access. That extended attributed data or metadata that's assigned or associated to, that curb line or that pavement. So the model, I won't say is a throwaway, it's still vitally important to them, but it's really the digital data that's associated within the model or attached to the model or linked to the model that's important for them. And that's really where industry's heading.
Thank you for that. And we're rapidly running out of time, like we always do. But I do have a question that I really want to put to both of you. I'm going to use Simon's question, good afternoon, as a basis. And he was asking Ross, can I ask what some of the typical obstacles to the uptake of digital engineering systems and tools by developers, consultancies, and contractors? But I'd also like to put a spin on that as well, is that for both of you, what do you think are the opportunities, as we put a future lens on that question? So the obstacles, the current obstacles, we talked about cost, but maybe other considerations, and then how do we see that we will break down those barriers going forward? Ross.
Okay, so the initial obstacles, I suppose, is understanding. Does the client who's conceiving the project understand what they want to get out, or are they using a commercial cookie cutter from their previous successful project, and therefore this is the deliverables they expect, this is the way they want to move forward, or are they willing to push the boundaries of how they do their work and what they engage their consultants and advisors to do to deliver them a more future ready deliverable and solution. So for me, it's very much the understanding from the client point. But that said, within the consultancy team, there has to be a level of experience and capability, and to be able to communicate the benefits and value for some of these things to a client who may not be up to speed with the cutting edge of what's available to them. And so it's that early stage communication as the project is being defined really allows these communications to be had. And then I suppose finally, engagement with the contracting team. It's all very well that it's all very well that the client has engaged the consultants to bring this future-ready digital products to bear. But if the contractor is not engaged and willing to and able to deliver the project in that manner, and hasn't priced and planned for that, then it's a non-starter. So you need to make sure that all parts of the supply chain are engaged and ready to deliver. And then I did forget to think about it, but obviously this is something that relates to that previous question. Who is the operator of the project? And how are they going to use the digital twin that might be produced? Have they bought into that? Do they understand the costs? Do they understand the benefits? That digital twin can be used during construction to enable metrics and value engineering and progress to be delivered to the client. But it's also used once the project is finished to enable that maintenance and forward planning on what they might do throughout the life of that building. But there's an overarching capital cost and maintenance cost for that model. If I give you a three-dimensional federated model today, and it will be out of date the moment the maintenance team has made a change. And if that team then doesn't update the digital model within a short period of time, the federated model isn't going to be worth the amount of money that was invested in that original contractual piece.
Thanks, Ross. Do you want to give us some closing remarks, Dave, from a solution perspective?
Yeah, so just going back to that last question, I think was asked, what's the obstacle?
Obstacles, yes.
Yeah, so the obstacle, we're quite fortunate within the civil transportation infrastructure area, because it's usually driven by the state governments. So it's really up to their requirements. So if they don't request that, guess what? As an industry, we're not going to go down that path. But as soon as we start seeing that filter into the contractual agreements, this digital engineering transition and the requirement for more digital engineering, guess what? As an industry, we need to support that. So state governments at that level are both the obstacle, but they're also the driver. And they're starting to drive that car pretty quickly now. So if you haven't bumped into those requirements through your workflow within any projects that you're currently working on, I can suggest that the next project or the next project, there will be evidence of that digital engineering requirement to be included within whatever you deliver back to the client or the owner at the end of the day. So I think it's a bit of a warning. Get on board because it's coming. So get an understanding of what those requirements are. Get an understanding of what you may need to deliver in the next project or the project afterwards, and be prepared for it. If you're not prepared, you'll get left behind.
Thanks, Dave. And that is all we have time for today. And I do apologise for people who put through questions and we didn't have a chance to get to them, but I'm sure we'll be doing future webinars on this topic. Please join me once again in thanking Ross Harvey and Dave Boddy for sharing their time at today's session. I'd also like to warmly thank Engineers Australia's long-standing industry partner, Bentley Systems, for making it all possible. As always, we're looking for your feedback on today's program, help us improve and plan future sessions. So if you could please complete a short feedback form linked in the description box below. It's been a fantastic session, learning more about the future of digital engineering with a focus on civil engineering. And on behalf of Engineers Australia, thank you again for joining us, and we look forward to seeing you at our next webinar. Thank you and good afternoon.